Welcome to Parabolas Day 1. This is actually also section 10.2. So what we're going to be doing today is graphing parabolas, and you've already graphed a parabola. Remember y equals x squared? That is what we're doing today, but we're also going to add to it a y squared graph, and we're going to be more specific with our graphing today. So we're going to be more advanced than what you learned back in Geometry 2. Now, a quick question. Do you remember back from Geo 2 what would make this open up or down? Okay, hopefully you were thinking if we have a positive, it goes up, and if it's a negative, it goes down. All right, we're going to work on graphing today, and we're also going to create equations for these parabolas. So I need to give you a few definitions before we start. First of all, the center of our parabola is a fancy way of saying the vertex. And today, all of the equations we're going to do have vertex of 0, 0, so centered at 0, 0. And then 10.2 part 2 is parabolas that are not centered at 0, 0. So today, all parabolas with a vertex of 0, 0. What's going to happen with our parabola is we're going to define two new things that you haven't learned about before. One is called the focus. A focus lies on the axis of symmetry, and the focus is a point. So it could be an ordered pair x comma y. And the directrix is a line we're going to draw, and the directrix is perpendicular to the axis of symmetry. So I guess before I do anything else, I need to remind you what the axis of symmetry is, in case you forgot. But again, focus lies on the axis of symmetry, and the directrix is perpendicular to the axis of symmetry. Let's suppose that I had this parabola like this. Just a quick reminder, axis of symmetry is the line I could draw through my parabola that cuts it exactly in half. And then to create the focus, the way the focus and the directrix are created is that the focus and directrix are made, so we're going to call that the directrix. Anyways, these are made so that any point on the parabola is equidistant from the directrix and the focus. So it doesn't matter where on the parabola I go, if I draw, and my picture isn't very good, but if I go from the focus to my parabola line and then I go to the directrix line from there, those should be an equal value. Let's write that in words. So for a parabola, specifically the line of the parabola, any point on the parabola is equidistant. Any point on the parabola is equidistant from the focus and directrix. In case you're feeling confused right now, don't worry, it's not that bad. Basically, the focus and directrix also, for our purposes, are just going to help us see which way our graph is going, and it's going to help us create an equation of a line. This is just the y behind it. We don't need to really, we don't use that when we're actually graphing. So if I kind of lost you there, that's okay. All right, so here's a review from your past. Remember an equation of a parabola. In the past, we said it was like this. I just want to say, just like how a straight line has different equations I can use. Remember, for a linear equation, here's just two of the examples of equations I could use. A parabola also has more than one equation you could use for it. So this is what you learned in Geo 2. Now we're going to learn a different line equation for a parabola. You probably didn't even know there was more than one. So here it is, x squared equals 4py, or y squared equals 4px. That number is always going to be 4. That's just part of the equation. The focus point is always going to be, for the x squared one, 0 comma p. And now the reason is, for the x squared, that's just the typical up or down like you've done before. So the focus is going to be 0 comma up high, because it's right on the y-axis, and the first point or the first digit, I don't know, coordinate is 0 because it hasn't moved left or right at all. And then the directrix is the line y equals negative p. That's an equation of a line. A y equals is a horizontal line, and then the axis of symmetry is the line x equals 0, because all the ones we're doing today have a vertex that's going to be at 0, 0. So not until we get to 10.2 part 2 are we going to see ones that don't have a vertex at 0, 0. And I am erasing that because I actually left 4 boxes right below this where we're going to draw quick sketches. So you didn't need that that was just my explanation sketch. For y squared equals, everything's flip-flopped. So now the focus point, p, is the x value, and the directrix is going to be the line x equals negative p. And a x equals is a vertical line. And then the axis of symmetry is horizontal, and it is the line y equals 0. And this is a vertical line right here. Okay. Pause if you need to get all that down. Now, I'm just going to show you a quick visual of what your graph should look like, and then what we're going to do is make more specific graphs. So these are just some examples of what, just in general, I guess I should say. First of all, x squared is always going to be up or down. That's the thing that you learned in the past in Geo2. So if I have x squared equals 4py, if the p is positive, my sketch looks something like this. And again, this is just a sketch, and then when we do our actual graphs, we'll do specific points. So I've got the vertex at 0, 0, and again, that's because everything we do today is going to have a vertex of 0, 0. The focus is right up here, right on the y-axis, and the directrix is going to be right down here. And the directrix is the line y equals negative p. So I've got my focus up here, 0 comma p. I've got my directrix, which is the equation of the line y equals negative p. It's y equals because it's horizontal. Now I'm going to go through and I'll do a little quicker sketch of the other ones, so feel free to pause whenever needed. So if p is negative, it's going to go downward. My vertex is still at 0, 0 because everything we do today is at 0, 0. The focus is now below, and so I just want to point out to that one way that graphing the focus helps us graph is our parabola always opens towards the focus and away from the directrix. So our graph always goes towards the focus and away from the directrix. So that's another way that the focus and directrix can help us graph, and I'll say more in a little bit. If it's a y squared graph, it's going to go right or left. And if it's positive, it goes to the right. And again, opens towards my focus. And opens away from the directrix. And if p is negative, it opens to the left. And again, opens towards the focus and away from the directrix. So as you're going along, while you're graphing, you can always come back to this picture and check to see if it looks like your graph is going in the right direction, depending on what your p is and if you have y squared or x squared. So this is just kind of like a visual check for you. Now to actually make this graph happen, the first thing that we're going to do is we're going to make sure that our equation is written in standard form. And today, standard form is the new thing that I just created. So, or I didn't create, but the new thing that we just learned. Okay, so I'm going to rewrite it in standard storm. I am recording this during the first snowstorm of the year, so you can tell what is on my brain. Rewrite in standard storm. Alright, anyways, it should have been standard form. Okay, so either I have x squared equals or y squared equals. That's my first step. Next, I need to solve for p, because p is going to tell me what my directrix and my focus are. And by the way, 4 times p is equal to the number that is in front of the x or y. And then next, we're going to determine what our focus and our directrix are. So step 3, we're going to determine what the focus and the directrix are. And step 4, we're going to make a table of values and plot the points. Sometimes I tell my students, if all else fails, everybody knows how to make a table of values to plot some points. So if you get really lost and you don't really know how to make these focus and directrix or something, you get to the test day and you're totally blank, everybody can make a table of values and plot the points to get yourself some partial credit at least. We're going to go through that step by step with the first one on the back. And I'm going to leave these directions up here as best as I can while we do these so you can see what I mean. So step 1, rewrite it in standard form. This time I have a y squared, so my goal is to make this one y squared equals to the 4px. Now, to get rid of a negative 1/6 times my y squared, I am going to multiply by the reciprocal. And then that and that cancel, and I'm just going to rewrite it so y squared's over here so it better matches our format. So I get y squared equals negative 6 times x. So that is step 1. I just rewrote it. And now I want to point out something right now. This, whatever is in front of x or in front of y, is 4p. And 4p is the formula. It's never going to change. So in order to find what p is, because I need to know p to find the focus, I'm going to take my number, negative 6, and set it equal to 4p, and then solve for p. That's what I mean by step 2 up there. So I'm going to divide by 4, and p ends up being negative 3/2. And now the reason why I care about p being negative 3/2 is we just learned up here that my focus is at p comma 0 or 0 comma p. I can figure out which one of those it is because if it's a y squared graph, I know it's opening left or right. So my focus is going to be the p comma 0 variety. So step 3, I'm going to determine my focus and my directrix. The focus then is negative 3/2 comma 0. And the directrix, when I always keep saying that it's the opposite of p, it's going to be the opposite of negative 3/2, or when I say negative p, so my directrix is at x equals 3/2. Now always do kind of a quick mental check to yourself. It's a y squared graph, so I know it's supposed to open left or right. I gotta, to make sure I did my focus and my directrix correctly, we graph them, and then in my mind, I want to ask myself, would this lead us to a graph that opens left or right? And it would, because my graph, remember, has to open towards the focus. So we're good to go. When I do step 4, which is creating my table of values, by the way, I'll just let's label our stuff quick. So the directrix is x equals 3/2, and the point is negative 3/2 comma 0 for the focus. All right, anyways, when I create my table of values, be strategic. When I look at this, I know my graph is going to open to the left, and I should have known that anyways because it was a negative 6x, so it opens to the left. But I don't need to I don't need to find too many points, but I don't want to pick any positives because that's not going to be on the graph, obviously. So I would pick things such as -1, -2, -3. And then what we need to do is we need to take our equation, which is y squared equals negative 6x, and I need to plug that in and then solve for x, or sorry, solve for y. So for when it's negative 1, I get y squared equals 6. Square root of 6 is 2.45, so let's just say 2.4. And when I am solving, remember that you do that plus or minus thing? So plus or minus 2.4, that totally makes sense because when I'm doing this, my parabola is gonna, you know, it has two different kind of legs or arms to it. So it makes sense that there should be two answers. Now I'm gonna go through and find the other two. So I get for x equals negative 2, y squared equals 12. Which ends up being 3.5 if I round it, so plus or minus 3.5 for my next point. And we'll just do one more. Y squared equals negative 6 times negative 3, so the square root of 18. 6 times 3 is 18, about 4.2. And then draw in your graph. So let's just throw it out there. Required parts. You must show your focus and your directrix, label them, and then you need to have 3 sets of points. And when I say 3 sets of points, even when my graph opens up or down, because it's symmetrical, once I find one side, I'll know what the other side is immediately. I'll show you in a second. All right, there it is. Write down questions you have, and then let's go on to number 2. So number 2 is an x squared graph, so I know that this one's going to open up or down. Step 1, let's put it in standard form. So x squared equals 40y. Step 2, I need to solve for p, and remember whatever is in front of the variable is for p. Alright, let's divide both sides by 4. It turns out this time that p is 10. Okay. So now I need to figure out, is my focus 0, 10 or is it 10, 0? And here is where you can be a little bit strategic with your thinking. If I know that it's going to open up or down, it's going to open up or down. So my focus needs to stay somewhere on my y-axis. So it can't be this one, because that one would be way over here. No, it has to be the 0, 10, because that's the only one that would lead me to have a graph that opens up towards it. Now I'm erasing because we'll be more specific with what I said, but I just wanted to say that's how I figured out 0, 10. Another quick way of knowing it is if y is with the number, the focus goes, p goes with y. That's another way I think of it. Okay, and then the directrix. This is a y value, so y equals negative 10. I don't have enough grid lines for you, so we're going to label them 2, 4, 6, 8 in order to make this graph happen. 2, 4, 6, 8 in each direction. Okay, so again, my center is at 0, 0, because that's how I'm graphing them today. My focus is at 0, 10, and the directrix is at y equals negative 10. So again, graph them, label them. You get points for doing that. So required part of your graph. Last but not least, I need to create a table of values. And again, be strategic. This time I know that it's going to open up either way. So I can do 1, 2, 3, that kind of thing. And then once I have those 3 points, I can just reflect them across the axis of symmetry to get the other side. And this is where it gets a little bit harder because, look, I've got x squared equals 40y. Okay, so when I plug in a 1 for x, well maybe this isn't that hard, I guess, but I get 1 squared equals 40y, and then I'm going to solve it. So 1 divided by 40 is basically what happens for that one. And when you're finding your table of values, it's going to be a little bit different every time, so sometimes that throws people off, but that's how it is. And now, you know what? That was a really small number. So I am rethinking my decision of doing 2 and 3. Let's change our minds and let's do 4 and 6. It's very likely those will be much bigger than 2 and 3 were. For the y values, they'll be easier to graph. So now I'm going to do 4x squared equals 40y, and x is 4. So 16 equals 40y. 16 divided by 40. is 0.4. Okay, those are still pretty small. And then 6 squared, which is 36, equals to 40y divided by 40 divided by 40. And again, it's x squared, which is why I did 6 squared. 36 divided by 40 is 0.9. All right, so I'll graph the ones on the right side, and just do your best to kind of 0.025, you basically can't even graph. Just do your best to graph it, and then I can reflect those across is the secret, because I know that the graph is going to be symmetrical. There we are. Okay, I've got 2 for you to try on your own right now. So why don't you pause the video, and when you unpause, I'm going to have the answers for 3 and 4 showing. And I'll show all the work too, so if you're still feeling kind of confused, you can read through that and follow along with. All right, so let's talk about this a little bit. So remember, step 1, solve, so it's y squared or x squared. Step 2, take that number in front of the variable and set it equal to 4p and solve for p. And then step 3, figure out what your focus and your directrix are. And remember my little shortcut I gave you. If it's with an x, the p is an x value. Directrix is an x value. So here I go. I got my focus at 1/3, comma 0. My directrix at x equals negative 1/3. And then you can see that for D, I'm going to scroll down a little bit and then I'll scroll back up. I just want to show you. Here is how I found my points. Eventually I decided just to jump up to 5 because these were not very big. And again, you always take your equation and plug in your x value and then solve it. And so that looks a little different for C or 3 versus 4, because for 4, then I have a number with y I gotta divide, and for 3, you had to square root it. Go ahead and pause and write that down if you want to. We're going to talk about how to create an equation next, and if you're kind of feeling a little overwhelmed, this part's easier. So this part's easier than graphing. So when you're ready, go ahead and look at the bottom of your page. So here's what we're going to do to write our equation. Based off of the information that they give us, we're going to find our p, and then we need to figure out if it's an x squared or a y squared equation. So first I'm going to find p, then I'm going to figure out if it's an x squared or a y squared equation, and I'm going to say more about that in a minute. And then you plug in your p value into whichever one you've decided it is. And let me just, so actually maybe I'll just say it now while you're writing stuff down. Remember that I said if it goes with a y value, the focus is going to be a 0, comma y, and if it's with a x value, the focus is going to be x, comma 0. That's one way you can think of it. And another way you can think of it is drawing yourself a little sketch. When you sketch it, then that way you really know what's going on. Okay, so here we go. And all of these have a vertex of 0, 0, because that's what we're doing today. Tomorrow we'll do the flipped ones, or the moved ones. So here I have my focus is 4, 0. So I know p equals 4, because my focus is always p, comma 0. Now because that is an x value, and again, I could also just graph it. So the focus is going to be over here. I know my graph has to open towards it. So it's a sideways graph, which means it's going to be a y squared graph. Left or right is y squared, up or down is x squared. So then what I do, once I have drawn my little picture, sorry, I probably erased that too fast. That's just my little quick sketch. I know my graph opens towards my focus, is how I figured that out. All you do then is take your equation and plug in p. So I say y squared equals 4 times 4x. So my final equation is y squared equals 16x. Here's another one. This time my p is a negative 3/8. If I make a little quick sketch this time, 0, comma negative 3/8 would be right down here. And so my graph is going to open downward like that. So then in my mind I'm like, okay, up or down, that's a x squared. Here's my formula. And then all I need to do is plug in p. Figure out what that is. It ends up being negative 3/2. So x squared equals negative 3/2 y. And then let me show you what it looks like if you're given the directrix instead. So remember how the directrix is the opposite of P? So if the directrix is y equals -2, we know that the focus is at 0, +2. And I put the 2 in the y spot because it was a y. Here, if the directrix is -1/2, I know that the focus is 1/2, 0, and I put it in the x spot because I was given an x. All right, then, last but not least, in my mind I'm thinking about the information given. There's my focus, there's my directrix. I know that it has to open towards the focus, so this has to be an up or down graph, which means it's the x squared type. Okay, so x squared equals 4 times 2 times y. Remember, the directrix is the opposite of what P is. So if P is positive, the directrix would be negative. And then for this one then, 1/2, 0. This one's going to open, so there's my 1/2, 0. It opens towards the focus, so this one's going to be a left or right one, which means it's a y squared one. So again, you're just making a quick stretch, depending on where the graph is opening towards, tells us if it's y squared or x squared. And then my P is actually 1/2. So y squared equals 2x for the final answer for that one. Go ahead and rewatch anything you need to, and thanks for listening. We'll talk to you again soon.